Hello, this is Dr. Kraus with another Intro to PLC video, this time talking about timers. There are three kinds of timers: the TON, which is a timer on delay, the TOF, which is a timer off delay, and both of those are non-retentive. We'll talk about what that means in just a second. And then the retentive timer on delay, or RTO. This is an example. So I have my rung 0 buffer inputs JSR, my final rung buffer outputs JSR. I've got an enable switch that's going to get the timer started, and then I've got output signals: timer enabled, timer timing, timer done. So this is the timer data type that has two dints. One is the preset value, which is what value am I timing up to. And then I've got the accumulated value, meaning how many milliseconds have I currently timed. And then the enable bool, the timer timing bool, and the timer done bool. The primary difference between the TON and the RTO is that in an RTO, it's going to remember how much time has passed, even if you turn it off, and you'll have to intentionally reset it to get it to go back to 0. Whereas with a non-retentive timer, every time its enable signal goes low, it also sets itself back to 0. So let's do examples of TON, RTO, and TOF. So in this video, I want to demonstrate to you first how a timer on works, a TON. I'm starting from a mostly blank project, but I'm going to encourage you to do the same. At the end of some of our previous videos or previous labs, we should have had input and output buffering working, and then I've got my JSRs that go to those two things. And so I'm saving this, and I called it blank with buffering. And I'm just going to keep that on my hard drive so that I always have the option to come back to this point if I want to start something new. And then I'm going to immediately go to File, Save As, and then give it a different name. So in this particular case, I'm trying to do a timer on demo. Now, if you don't know how to get to this point, then I think maybe a previous video edit answers that question. If not, let me know, and I can create a video on how I did that. So now I want to add a timer on. So I'm going to put that rung in. So I'm going to buffer my inputs at the first rung, 0th rung. I'm going to buffer my outputs in my last rung. And then under timer, I'm going to grab a TON. And I'm going to have an enable that is an XIO. And I'm going to use I think I call that PB0. I may have toggled back and forth between calling this in00 versus PB0. Sorry if that causes confusion. So we're good there. That's not what made my rung red. It doesn't know what my timer is. And so now I'm going to create my first timer variable by double-clicking in this box and giving it a name. And it's still mad at me. So now I'm going to right-click on it and say New Timer. And what this is going to do is default to assuming I'm trying to create a timer data type. And we'll talk about that in just a minute. But a timer has 2 dints and 3 bools, I think. And so I'm going to create that. And I'm going to give it a preset value of, let's say, 2,000 milliseconds. So it's going to run for 2 seconds. And I think right now, if I went online, this would be enough to get us started. Oops. Oh, man. I'm sorry. So it's going to have to do the whole whoactive thing, and this might take a second. I want to go online with that thing. So I enable my timer with PB0, and it counts up to 2,000, and then it's done. And when I turn it off, because a TON is non-retentive, it goes back to 0 and its accumulated value, and then it counts up to 2,000, and then it's done. Now, in and of itself, that might not be super useful because how do I access this done signal, for example? Well, I'm glad you asked. So if we look at the timer data type, like I mentioned, it has two D-ints, double ints, whatever that stands for, that hold the preset value, which is what I'm trying to count up to, and the accumulated value, which is what I've counted so far. And then I've got three bools. Am I enabled? Am I currently timing, TT, timer timing, or am I done, DON? So let's come back to our main routine. Let's add, whoops, not sure what I just did there, but I made my toolbar all gunky. And for no particular reason, I'm going to do this in online mode. I'm going to drop that in there, and I'm going to drop that in there. And so this will be my timer, and I'm going to hit the right arrow and say .EEN, enabled. And I'm going to put that on pilot light 0, and then I'm going to copy and paste again. And then this will be TT, and this will be done, and this will be PL1, and this will be PL2. I will accept all of those edits and I will finalize them. Yes. Okay. It doesn't quite fit in. There we go. So what I want you to see is I'm going to flip on this enable. The enable out light will come on. It will then be timing for 2 seconds, and then once it's done, timing will go off, done will come on. It's unfortunate. There we go. So let's watch that one more time. Now again, notice this is a non-retentive timer, TON. So as soon as the enable goes low, the accumulated value goes back to 0, and then it counts up for 2,000 milliseconds. While it's counting, TT is high and done is low. Once it's done, TT is low and done is high. One more time on that. Now it's still enabled, but it's done, so it's no longer timing. So that is a timer on delay. Okay, so now I want to demonstrate the difference between a timer on, a TON, and a retentive timer or an RTO. So I'm going to, I think if I go offline, I can double click in this box, and I'm just going to put RTO here just for a quick change. And that's enough to demonstrate the difference between the two to get us started. I think. Let's find out. Now I think because I didn't reset my accumulated value before we started this, nothing's going to happen when I flip this switch once it all downloads. So it currently says that it's done with an TON, a non-retentive. When I turn it, when it's disabled, when the enable goes low, it automatically resets to 0. That is not the case with an RTO. So I could come in here and manually set this to 0, and then it would time. No. So manually resetting that didn't actually do what I wanted. Okay, I learned a thing today. So what we need to do to really solve this problem is drop in a new rung. We're going to use PB1 to reset our timer. So under timers, it looks like, it looks a little bit like a latch or unlatch with just RES in the middle, but it is actually a different control. So you find it with the timer counter tab, RES for reset. I'm going to finalize those edits. And now what I want you to see is that when I press PB1, it resets the timer, and now it's no longer done. And I think we'll see in a minute that so one, if I let it run for just under a second and stop it, note that it remembers where it let off. And so now it's not done, it's not enabled, and it's not timing, but it remembers that it was at 669 milliseconds. And so if I then re-enable it, it starts from there, not from 0, it counts up to 2 seconds, and then it knows that it's done. But now if it's not enabled, it stays done, and it'll stay done no matter what I do on the enable side until I reset it. So again, count up for 2 seconds, done, stay done, reset. And if you got interrupted before you got to done, it does not go back to 0 when you turn the enable off. It is only the reset that sets it back to 0. So I don't know exactly what use case you would need where something needs to have a certain amount of time regardless of how long it was on or off, but that is what a retentive timer does. So to complete the timer demo family, the last thing timer that we haven't talked about is a TOF. So again, I'm offline. I can just come in here and type TOF, double click. I will not need a reset because a TOF is not retentive. And I think that's all it's going to take. And so what I want to show you is that the behavior of a TOF is just a little bit different from a TON. I think I've been told that TOF is pretty uncommon. The use case is that you would turn something off and you need to wait a certain amount of time before you turn another thing off. So the weird analogy that comes to my mind is back in the olden times, we had really expensive light bulbs in our LCD projectors in our classrooms when we were, projecting a PowerPoint presentation or something onto the wall. And so after you turn the projector off, you still wanted the fan to run for a certain period of time to cool that light bulb off because the bulbs were $4 million or something. I'm just kidding. But so that's the idea. You turn the main thing off, but you still need this other thing, some kind of cooling or something, to run for a certain period of time and then shut off. So that is what the TOF is going to do. So I'm here. Yep, and it already did its thing. So what I want you to see is, so PB0 represents the enable to the timer, but it's also this other thing that's running. So this is the power to the projector in my silly analogy. And then when I turn it off, so right now the timer is enabled, but it's also done, and it's not timing. When I disable the power to the projector or whatever, then the timer starts to time. It counts up to a certain amount of time, and then once it reaches its preset, all the signals turn off. It's no longer enabled, it's no longer timing, it's also no longer done, which is a little bit of a weird way to talk about it, right? Because it starts out done when it's enabled, and then it stays done until it's actually time to turn off. So they're kind of confusing, and I think that's part of why they're not often used in industry. But again, something else is running, that thing turns off, I need my cooling fan to stay on for as long as my timer is timing, and then everything shuts off. So enabled, it resets itself to 0 here, it's enabled, and it starts out done, and then it's timing for the amount of time specified, and then when it's actually done, everything turns off. Meaning the done signal is no longer on, which is a little weird. So it starts out done and ends not done. But that would mean that the done, maybe this is the controller to the cooling fan or something in my analogy. I don't know. It's a little weird, but if you find yourself in a situation where as part of your shutdown procedure, you need this one last thing to stay on a few minutes or seconds or whatever longer than everything else, then maybe a timer off delay is a good application.